Hey everybody, welcome back. Let's go ahead and start our new notes for section 2.7A, the composition of functions. So I'm hoping that this feels really familiar to you, that this is kind of an easy retransition back into compositions of functions. So let's talk about it. So the composition of function means that we take one function and we substitute it into the other function. So this reads f of g of x like that. So f of g of x. It means that the output of g of x is used as the input for f of x. So let's practice some of this. So it says let f of x equals x squared minus 4 and g of x equals 3 minus x. So these are two separate functions. But now it says, hey, find f of g of 5. So in order to know what our input is, let's find it. So let's find what is g of 5. Well, g of 5 means I'm going to use this function, and instead of x, I'm going to input 5 instead. So 3 minus x is now 3 minus 5. When I evaluate that, I know this is negative 2. So g of 5 is negative 2. So now when I reevaluate this, I know I can use this instead. So f of g of 5 is the same as f of negative 2. I'm substituting it in. So now I'm going to say, hey, instead of x, I'm going to plug this in here. So x squared minus 4 is now negative 2 squared minus 4. Well, I know that's 4 minus 4, which is 0. Okay. Why don't you try part B, push pause right here. Go ahead and try it on your own. All right, let's see what you did. So let's find f of 5 first. And to find f of 5, we're going to take, instead of x squared minus 4, we're going to put in x as 5. So then this becomes 25 minus 4, which is 21. So f of 5 is actually 21. So to find g of f of 5, we're going to use 21 instead. And we're going to plug that into the g of x equation, which is really 3 minus 21, which is negative 18. Okay, so here we've practiced this f of x, but f of x can also be written as, you might see this every once in a while, f of g of x. It says the same way, but we might see it occasionally that way as well. So what if we wanted to use tables instead of the actual function? So let's say we don't know the function. We can actually use a table of values instead. So remember here, our input is g of 0. Well, I know g of 0 means that when x is 0, I'm going to see what happens when we set it into g of x. Well, that's 3. So now to find this, I'm going to say f of g of 0 was actually 3. So now our input now is 3, and we're going to put that into function f, which is just 2. Let's look at the next one. So I know my input is g of negative 2. So we're going to go again to negative 2, and we're going to plug it into the g function, which is negative 5. Well, this is now, instead of f of g, this is f of g of negative 2 is now negative 5. So here's our negative 5. Plug it into the f function, and we get 3. Go ahead and pause and try number 5. All right, let's see what you got. Let's find f of 2. F of 2 is right here. It's at negative 3. So how do we find g of negative 3? That's like saying g of negative 3. Plug in negative 3 here. Plug it into g. We get 7. Okay, it says use the graph. So now instead of using the function, instead of using a table, we're actually going to use the actual graph, okay? So here, I know to find g of 1, remember this is when x is 1. So we're going to look to see when x is 1, so that's here, when x is 1, follow it up to the g function. So we see that the g function is here, and here's the f function. So when x is 1, we're going to follow it down to the g function. Well, what's that output value, or the y value? We see it's at negative 1. So we know g of 1 is actually negative 1. So to find f of negative 1, my input is now going to be negative 1, and we're going to follow it up to the f function, which tells me that that value, the output value, is 3. Let's try the second one. So again, we're looking for what's f of negative 2. So when x is negative 2, follow it to the f function that's already there. That's a 0. That's at y equals 0. for its output. So now we're going to use that as the input for g of 0. So let's find when x is 0, what's g? Well, here's our g function. So at 0, g is also right here, 0. All right, go ahead and push pause and try this one on your own. All right, let's see what you got. What's f of 1? Well, it's again, when x is 1, we follow it to the f function. We got 3 as the output. So to find g of 3, we're going to say when x is 3, the g function is right here. That's negative 1. Oops, this is a 1, sorry, negative 1. All right, and then lastly, I want you to go back into previous u. We're going to recall the additive identity is 0, meaning you can add 0 to any number and it gives you the same number. Same thing with the multiplicative identity is 1, which means you can multiply any number by 1 and it gives you the same number. So let's apply this to what we just learned. The identity's function is this. It's f of x equals x. This is really important. So identity function, okay, equals just x. And that's because when it's composed with any function, g of x is always going to be the same function back. So if f of x equals x, when I plug it in back, I'm going to get also g of x. Okay, so the identity function is x. Any composition of it will stay the same. All right, that's it for today. I'll see you in class.